Okay, students, let's start with the past papers for AS Physics Waves. In this chapter, we will be specifically seeing MCQs related to waves, and let's start with it. Let's start with the first MCQ, that is the range of frequencies, okay, emitted by blue whale is from 10 hertz to 40 hertz. Perfect. The speed of sound in seawater is this. Perfect. What is the approximate range of wavelengths of sounds emitted by the blue whale? Okay. So we are given the frequency range, we are given the speed, we have to calculate the ranges of wavelength. How are we going to do that? Very, very easy. We know V is equals to F lambda. What is your speed? 1.5 kilometers per second. So this will become 1500 meters per second. What is the initial frequency? The initial frequency is 10. What will your initial or the first lambda become? 0 0 cancel out, lambda becomes 150 meters. Let's do the same thing for 40 hertz. V is equals to F lambda. V is what? 1500. Frequency is 40. Lambda 1500 divided by 40. Your 38 comes out to be your lambda. So lambda should be in the range of 150 meters to 38 meters. Any answers like that? D is your answer. Perfect. Let's further move ahead. Okay, let's see this question. A beam of light with power P has a cross sectional area of A. The amplitude of light waves in the beam is x. Perfect. The beam of light is then changed to the same frequency but with an increased amplitude of 4x. Perfect. And a cross sectional area of A over 3. What is the new power of the beam? We have to calculate the new power of the beam. Perfect. We know that intensity is equals to what? Power over area. Okay. Initially, your power is P. Intensity into area is equals to your power. Perfect. Now, the change that we are making is we are increasing the amplitude from x to 4x. Basically, we are making the amplitude 4 times. And we have studied intensity is directly proportional to amplitude square. So intensity will increase from a factor of I to 16I. Perfect. Can you calculate the new power now? Yes. In the new power, your intensity is 16I. What has happened to your area? Your area has become A over 3. So we can say 16 upon 3 is equals to 16 upon 3 IA is equals to the new power. We can replace this IA with what? With power P. Okay. What does your new power become? 16 over 3P. This is equals to 5.3P. B is your answer. Let's further move ahead. A transverse wave on a rope has a wavelength lambda and time period t. Perfect. The graph shows the variation of the displacement of the particle on the rope with distance in the direction of travel of the wave at time t is equals to 0. A particle x is labeled. Okay, this particle x is labeled. Which graph shows the variation of the displacement of particle x with time? Okay, we have to calculate the displacement of x with time. So the easiest way to mark the displacement of x with time, what will you do? You will draw an imaginary line through it and you will reciprocate the wave at the back. Somewhat like this. Any options like that? C is your answer. C is your answer. Let's further move ahead. Let's see this. X and Y are 2 points on the surface of water in a ripple tank. A source of constant frequency generates a wave which travels past X and Y, causing them to oscillate vertically. What is the phase difference between X and Y? We have to calculate the phase difference between X and Y. If X was here, this would have been the turf. If X was here, this would have been the turf. The distance or the phase difference between the turf and the crest is what? 180. But your x is slightly more towards the left. It is here. It is somewhere here. So it will have a phase difference greater than 180. All of these will get cancelled out. D is your answer, 270. Okay, let's see this question. Two waves pass through a point P. The graph shows the variation with time t of the displacement s of the two waves at point P. What is the phase difference between the two waves at point P? You have to calculate the phase difference between the two waves. So whenever you have to calculate the phase difference, what's the first thing? You see the point where the two waves pass the x-axis. This blue wave is passing the x-axis at point 3, and this orange wave is passing the x-axis at point 4. Perfect. What is the difference between the two waves? The difference between the two waves is of 1 second. Perfect. What is the complete time period? The complete time period for one wave is 8 seconds. Okay. In 8 seconds, you are covering a complete wave that is how many degrees? A complete wave covers 360 degrees. How many degrees will you cover in 1 second? X. Cross multiply and calculate the answer. 360 divided by 8 is your phase difference, or X. Let's calculate that. 360 divided by 8. Your answer comes out to be 45 degrees. B is your answer. When sound waves travel through air, the air particles vibrate. A graph of displacement against time for a single air particle is shown. Perfect. Which graph shows how the kinetic energy of the air particle varies with time? Okay, so you have to tell which graph shows how the kinetic energy of the air particle varies with time. Perfect. Always remember, when you have a displacement of 0 or when you are at the mean position, at both these points, your kinetic energy will be maximum. You can write it here. At mean position or 0 displacement, your kinetic energy is what? Your kinetic energy is maximum. And at extreme positions, your kinetic energy is 0. Your kinetic energy is 0. What are the extreme positions here? The extreme positions are these and these. Perfect. And also this one as well. This one is also extreme position. Perfect. So this is telling me that throughout one time period, my kinetic energy should reach maximum 2 times and minimum 3 times. This is telling me that throughout one time period, my kinetic energy should reach maximum 2 times and minimum 3 times. Can you see option D? 1, 2, 3. Reaching minimum 3 times over the course of one time period and reaching maximum 2 times over the course of one time period. D is your answer. Let's see this. A progressive wave of frequency 1.5 kilohertz travels in a medium at a speed of this. What is the minimum distance between 2 points on the wave that have a phase difference of 70 degree? Perfect. So frequency is 1.5 kilohertz, 1500 hertz. Your speed is what? 340 ms minus 1. We will apply what? V is equals to f lambda. V is 340, f is 1500. Divided. What does your lambda come out to be? 340 divided by 1500. Your lambda comes out to be what? 0.227 meters is your lambda. Perfect. Throughout one wavelength, you are covering a phase difference of 360 degrees. To cover a phase difference of 70 degree, you will travel x. Cross multiply, calculate the answer multiplied by 70 divided by 360. Your answer comes out to be 0.0. X is equals to 0.044 meters. That is roughly equal to what? Take this decimal point forward, 4.4 centimeters. A is your answer. Simple. Let's further move ahead. In a progressive wave, two particles P and Q on the surface of water are a fixed horizontal distance apart. P and Q oscillate vertically. At time t is equals to 0, the wave is as shown. Perfect. Which graph best represents the variation with time t of the phase difference between the oscillation of the water particle P and the oscillation of the water particle Q? So, which graph tells us how the phase difference between P and Q will vary? Always remember, the phase difference between any 2 points on a wave remains constant throughout. Any answers like that? D, in which the phase difference is remaining constant throughout. Let's further move ahead. The diagram shows a transverse wave on a rope. The wave is traveling from left to right. At the instant shown, point P and Q on the rope have zero displacement and maximum displacement respectively. Which row describes the motion, if any, of the points P and Q at this instance? What have I told you? At maximum displacement, your velocity becomes zero, kinetic energy becomes zero. So Q will be stationary. B and C option get cancelled out. If you have to calculate the motion of point P, you will draw a dotted line here and will reflect the wave on the backside. Something like this. So P will be traveling downward and Q will be stationary. A is your answer. Let's see this. A longitudinal wave travels along a long spring. The spring is shown at one instant. What is the wavelength of the wave? Okay, we have to calculate the wavelength of the wave. So wavelength of a wave for a longitudinal wave is what? From rarefaction to rarefaction is also a wavelength. From compression to compression is also a wavelength. Here, if you analyze option B, you are going from a compression to a compression. That is your lambda. Simple as that, nothing complicated here. Perfect. Let's further move ahead. Okay, let's see this. A transverse wave of wavelength lambda is set up on a stretch spring. The graph shows the variation of displacement y with distance x at a particular instant of time. Perfect. The wave has displacement plus v1 at a distance of x is equals to pi over lambda over 8. What are the next two values of x where the displacement y is again equal to plus y1? First of all, the next set of value where displacement will be y1 is this. How can you calculate this? You can say this is lambda over 2 minus lambda over 8. Take an LCM multiplied by 4 multiplied by 4. This gives you an answer of 3 lambda over 8. So I will choose an option which has 3 lambda over 8. What will be the second point which gives you this? Somewhere here. This is also displacement y1. How can you calculate this? Lambda here. Lambda plus lambda over 8. This equals to what? 9 lambda over 8. So B is your answer. Simple. Okay, let's see this. A guitar string vibrates to create a sound. The speed of sound in the guitar string is 440 ms minus 1. The vibrating string creates a sound wave that moves in air with a speed of what? 330 ms minus 1. Perfect. Which graph shows the variation with frequency? Which graph shows the variation of frequency with wavelength lambda for the waves in the string and in the air? Always remember air is what? Gas. What is a string? String is solid. Okay. So which graph out of these shows the variation of frequency and lambda? First of all, you have to realize that V is equals to F lambda. Velocity in each substance, either solid or liquid, gets constant, and frequency is inversely proportional to lambda. So A will not be my option and B will not be my option. Out of C and D, C will be my option. Why? Because a string is a solid, and in solid my speed is greater, hence my curve will be shifted more towards the right. In solid, my constant speed is 440 ms minus 1. Hence, my curve will be more shifted towards the right compared to a gas where my speed is 330 ms minus 1. Let's further move ahead. Okay, let's see this question. Two waves x and y have the same frequency. The amplitude of x is 1.5 a naught and the amplitude of y is 2.5 a naught. The waves meet at a point and superpose to form a resultant wave. Perfect. For the resultant wave, what is the ratio of maximum possible intensity divided by minimum possible intensity? Perfect. If I want the maximum possible intensity, what should happen? The amplitude should add up. For maximum possible intensity, what should happen? Your amplitude should add up. Okay, what will happen? 1.5 a naught plus 2.5 a naught. This gives you a total value of what? 4 a naught. Perfect. If your amplitude is 4 a naught, what will be your intensity? We have studied that intensity is directly proportional to amplitude square. If your amplitude is 4 a naught, your intensity will be 16i. Perfect. And for minimum possible intensity, what will we have? For minimum possible intensity, our amplitudes will get subtracted. 2.5 a naught minus 1.5 a naught. This comes out to be a naught. If your amplitude is a naught, minimum possible intensity will be I. Let's divide both of them. Maximum is 16i. Minimum is I cancel out. 16 is your answer. D is your answer. Perfect. Let's further move ahead. The diagram illustrates the position of a particle in a progressive sound wave. Okay, so this is a longitudinal wave at one instant in time. Okay, the speed of the wave is v. P and Q are 2 points in the wave at a distance of L apart. What is an expression for the frequency of the wave? We have to calculate the frequency of the wave. Perfect. So this is a compression. This is a rarefaction. If you can see, this is the point where other points are close together. This is a point where other points are far away. From compression to rarefaction, your length is L. From compression to rarefaction, what is your lambda? 1 upon 2 lambda is equals to L. Lambda is equals to 2L. Perfect. What is your velocity V? Can we calculate frequency? Yes, V is equals to F lambda. V divided by lambda, that is 2L, is equals to your frequency. What is your answer? A is your answer. Let's further move ahead. The graph shows the variation with displacement y of the distance x along a progressive wave at one instant in time. Perfect. What is the phase difference between point P and Q on the wave? Okay, we have to calculate the phase difference between point P and Q. So if this is point P, this point, let's say x, will have a phase difference of what? The phase difference between Q and X will be what? 360 degree. Because this is also a crest. This is also a crest. Perfect. And from a crest to a turf, that is point P, what will be the additional phase difference? 180 degree. 360 plus 180 degree, 540 degrees is your answer. C is your answer. Perfect. Let's further move ahead. A vibration generator produces a progressive wave on a rope. The diagram shows the rope at one instant. The wave travels at a speed of this. Perfect. What are the wavelength and frequency of the wave? You have to calculate the wavelength and frequency of the wave. Can you see that one wave, two waves, and three waves are getting completed in a distance of what? 0.8 meters. So 3 lambda is equals to 0.8 meter. Lambda will be equal to what? 0.8 divided by 3. What does this come out to be? 0.27 meters. A is not your option. B is not your option. Now let's move on to calculating the frequency. V is equals to F lambda. What is V? 4 divided by lambda, that is 0.27. What will your frequency come out to be? 4 divided by 0.7. This comes out to be what? 14.8. That is 15. C is your answer. Frequency is roughly 15 Hertz. C is your answer. Let's further move ahead. Transverse wave travels along a rope. The graph shows the variation of the displacement of the particles in the rope with distance along it at a particular instant. At which distance along the rope do the particles have maximum upward velocity? So maximum upward velocity only occurs at the mean positions, either this, either this, either this, or either this. Perfect. So this is 0.5, this is 1.5, this is 2.5, and this is 3.5. Because maximum velocity always occurs at the mean position. So let's see, are there any other options? Okay, 1 gets cancelled out, 2 gets cancelled out. We have two options, either 0.5 or 1.5. We have two options, 0.5 or 1.5. Perfect. Now, if you observe at 0.5, if I draw a dotted line here and reflect this graph, yes, this is traveling upwards. A will be your answer. However, if I draw a dotted line here, your particle will move downward if I reflect this on the right side. So A or 0.5 meters is your answer. And if you check the marking scheme that I have attached with these, 29 has an answer of A. Let's further move ahead. Let's see this. The graph shows a series of moving pressure variation from the normal constant air pressure. The graph shows these pressure variations for two waves at one instant in time. Perfect. Wave 1 has an intensity of this. Okay, so what is wave 1? This solid line is wave 1. Wave 1 has an intensity of this. We have to calculate the intensity of wave 2. Perfect. So, do you remember this formula? Intensity is directly proportional to amplitude square. Intensity is equals to Ka square. Here the amplitude is what? 2. For wave 1, the amplitude is what? 2. Intensity is what? 1.6 into 10 raised to the power of minus 6 is equals to K. Amplitude is 2 into 10 raised to the power of minus 2 whole square. What does K come out to be? 1.6 into 10 raised to the power of minus 6 divided by 2 into 10 raised to the power of minus 2 whole square. Can we calculate this value of K? Yes. 1.6 into 10 raised to the power of minus 6 divided by 2 into 10 raised to the power of minus 2. Okay, whole square. K comes out to be what? K is 4 into 10 raised to the power of minus 3. Perfect. Now you have to calculate the intensity of wave 2. What is the amplitude of wave 2? 3 into 10 raised to the power of minus 2. Can I calculate the intensity? Yes, surely I can do that. Intensity is equals to Ka square. K is what? 4 into 10 raised to the power of minus 3. What is amplitude? 3 into 10 raised to the power of minus 2 whole square. Can we calculate this answer? Yes, 3 into 10 raised to the power of minus 2 whole square. This comes out to be what? 3.6 into 10 raised to the power of minus 6. Any answers like that? C is your answer. Perfect. Let's further move ahead. The speed v of waves in deep water is given by this equation, where lambda is the wavelength of the waves and g is the acceleration of free fall. Perfect. A student measures the lambda and the frequency of a number of these waves. Which graph should he plot to give a straight line through origin? Okay. So v square is equals to g lambda over 2 pi. Okay. So instead of v, what can I write? F lambda whole square is equals to g lambda over 2 pi. Perfect. F square lambda square is equals to g lambda over 2 pi. Perfect. Lambda cancel out. Lambda is equals to g over 2 pi over 1 over f square. So either you can plot a graph of lambda versus 1 over f square, or you can inverse this as well. You can plot a graph of f square over 1 over lambda. You can plot a graph of this. Any answers like that? Yes, D is your answer. Perfect. Let's further move ahead. A longitudinal wave is traveling from left to right. The graph shows the variation of the displacement of the particles with distance along the wave at one instant in time. Perfect. Displacement to the right are positive and displacement to the left are negative. Which label point represents a compression? Perfect. So this is a point which is at zero displacement. Let's make it here. This is maximum positive displacement, so this will come towards the right. This is a point again with zero displacement, this will come here. This is a point with negative displacement, this will come here. Perfect. Which point represents a compression? B. Simple. You can see at point B, these points are close together. The answer for 40 should be B, and it is B. Perfect. Let's further move ahead. The graph shows the variation of the displacement of an air particle with time as the sound wave passes through air. Perfect. Oh, what is this color of highlighter? The intensity of the sound is halved. Perfect. The frequency remains constant. So intensity goes from I to I over 2. Perfect. The four graphs are drawn to the same scale as the graph above. Which graph shows the displacement of the air particles? Okay, which graph shows the displacement of the air particles? So, okay. If the intensity is being halved, what will happen to amplitude? Amplitude will become what? Under root 1 over 2a. What is the amplitude currently? 4. What will the amplitude become now? 1 over under root 2 into 4. Oh, I think the space is less here. So let's do it here. The amplitude is initially 4. Now it will become what? 1 over under root 2 into 4. That is equals to what? 1 second. Under root 1 over 2 into 4. This comes out to be what? This comes out to be 2.82. Amplitude will now be 2.82 or roughly close to 3 boxes, and the frequency will remain same. I will cancel out option A and I will cancel out option B, because in these options the frequency is changing. Perfect. Any options where your amplitude is close to 3 boxes? Yes, D is your answer. Let's further move ahead. A transverse water wave is moving along the surface of some water. This causes a ball to move vertically without moving horizontally as it floats upon the surface. Okay, so as a transverse wave passes through this ball, it is moving up and down. Perfect. At one instant, the ball is in the position shown. The wave has a frequency of 0.2 Hz, perfect, and has an amplitude of this. The distance between a trough and an adjacent peak is 2.4 meters. What is the distance traveled by the ball in 20 seconds? We have to calculate the distance traveled by the ball in 20 seconds. Okay. So we are given the frequency. Can we calculate the time period? 1 over f. 1 over 0.2. Your time period comes out to be 5 seconds. So 5 seconds is your time period. How will the ball displace in 5 seconds? First of all, that's the main issue. In 5 seconds, the ball will go to the mean position. Then from the mean position to the minimum position, and then from the minimum position, it will again come to the mean position, and then from the mean position again to the original position. This is the motion of the ball in the 5 seconds. Okay, what is the total distance traveled here? 0 0.7, 0 0.7, 0 0.7, 0 0.7. The total distance in 5 seconds is what? 2.8 meters. What will be the distance in 20 seconds? 2.8 into 4. 2.8 into 4. This comes out to be what? 11.2 meters. C is your answer. Perfect. Let's further move ahead. A wave travels along a coiled spring. The graph shows the variation with time t of the displacement of a point on the spring. Perfect. You have to calculate the frequency of the spring. Okay. So one wave gets covered here. This is your second wave. This is your third wave. So 3 waves are getting covered in how many seconds? 0.4 seconds. How much time will it take for one wave to get covered? 0.4 divided by 3. This is your time period. Can I calculate the frequency? Yes, frequency is 1 over time period. 1 over 0.4 over 3. So let's calculate this. 1 divided by zero point 0.4 over 3. This gives you an answer of what? 7.5 hertz. D is your answer. Simple as that. Let's further move ahead. Two graphs represent the same wave. Okay, so these are two graphs representing the same wave. Perfect. Graph 1 shows the variation with time of the displacement at a particular distance. Graph 2 shows the variation with distance of the displacement at one instant. What is the speed of the wave? Perfect. We have to calculate the speed of the wave. How can we do that? This first graph can tell us the time period taken to complete one wave. Time period comes out to be what? 0.5 seconds. Okay. And the second graph tells us what? The wavelength. From this point to this point, what is the wavelength? Wavelength is 60 centimeters. That is 0.6 meters. Perfect. Now you have the time period as well. You have the wavelength as well. Can you calculate velocity? Yes, velocity v is equals to f lambda. V is equals to 1 over time into lambda. What is your 1 over time? 1 over 0.5 into lambda, that is 0.6. So 2 into 0.6. 2 into 0.6. This will give you a value of what? 1.2 ms minus 1. This is 1.2 ms minus 1. You will see no options like these here. So what will you do? You will convert this into centimeter minus 1. 1.2 ms minus 1 multiplied by 100 is equals to 120 centimeter s minus 1. D is your answer. 52's answer is what? D. Let's check it out in the marking scheme. Yes, the answer for 52 is D. Let's further move ahead. The graph shows the height of the water surface at a point in a harbor varies with time as wave passes the point. Perfect. What are P and Q? What is this P? What is this Q? P is what? The displacement. What is Q? Q is the distance traveled by one wave. Q is the distance traveled by one wave. That is lambda. B is your answer. Let's further move ahead. When a guitar string is plugged, it causes a longitudinal sound wave in the air as shown. Perfect. The speed of sound is 340 ms minus 1. What is the approximate frequency of the sound wave shown? Okay, we have to calculate the approximate frequency of the sound wave shown. Can you see this is also looking like a compression? This is also looking like a compression. The distance from compression to compression is what? 0.5 meters. Compression to compression, your distance is 0.5 meters. That means your lambda is 0.5 meters. Your speed of sound is 340. You have to calculate frequency. V is equals to f lambda. 340 divided by lambda, that is 0.5, will give you your frequency. 340 divided by 0.5, this comes out to be what? 680 hertz. B is your answer. Perfect. Let's further move ahead. The displacement time graph for a transverse progressive wave is shown. The phase difference between point x and y can be expressed as 180 n degrees. Perfect. What is the value of n? If you closely look, this is a crest. This will also be a crest. The distance, the angle between a crest and a crest is what? 360 degrees. And the angle from a crest to a turf is what? 180 degrees. 180 degrees. What will be the total angle? 540 degrees. What is this? 180 n. If you divide it by 180, you will get your answer of n. That is 3. C is your answer. Let's further move ahead. Let's see this. The diagram shows two waves x and y. Wave x has an amplitude of 8 centimeter. Perfect. This wave, let me highlight it. This wave. This has an amplitude of what? 8 centimeter. Perfect. And a frequency of 100 hertz. Perfect. What are the amplitude and frequency of wave y? Perfect. You have to calculate the amplitude and frequency of wave y. How will you do that? Very, very easy. First of all, amplitude is pretty easy to calculate. This roughly looks like half the amplitude. If this is 8, this looks like half the amplitude. So A and B will get cancelled out. Regarding the frequency, if you notice, one wave of X is covering how many waves of Y? One. Okay, let me take a different color marker. Yeah, this would suit perfectly. One wave of X is covering 3 waves of Y. That means what? The frequency of Y is 3 times the frequency of X. What is the frequency of X? 100. What will be the frequency of Y? 300. D is your answer. Let's check this question 68. 68 should have an answer of D, and D it is. Let's further move ahead. A sound wave is detected by a microphone and displayed on a screen of a cathode ray oscilloscope. The frequency is this. Perfect. What is the time base setting on the CRO? Okay. So if the frequency is this, can you calculate the time period? Yes. Time period is 1 over frequency. 1 divided by 2.5 into 10 raised to the power of 3. Let's calculate this. 1 divided by 2.5 into 10 raised to the power of 3. This gives you an answer of what? Time is equals to 4 into 10 raised to the power of minus 4 seconds. Perfect. This is your time period to complete one wave. The time taken to complete one wave is this. 4 boxes are being utilized to complete one wave. Okay. So one box will represent what? If 4 boxes represent 4 into 10 raised to the power of minus 4 seconds, one box will represent what? 1 into 10 raised to the power of minus 4 seconds. Perfect. Now, where do you see this? Where do you see this 1 into 10 raised to the power of minus 4 seconds? Anywhere you can see this option 1 into 10 raised to the power of minus 4 seconds. So basically, what is 1 into 10 raised to the power of minus 4 seconds? If I break it down further, like let's say one box represents this. Perfect. One box represents this. So if I break it down further, this is what? 1 into 10 raised to the power of minus 1 into 10 raised to the power of minus 3. Perfect. This becomes what? Milli. Okay. 1 into 10 raised to the power of minus 1 milliseconds. This 10 raised to the power of minus 3 has been replaced by milli. And here I have broken down 10 raised to the power of minus 4 into 2 powers. Okay. What does 10 raised to the power of minus 1 means? You will take this decimal point one place backward. 0.1 milliseconds centimeter minus 1 is your time based supply. Any answers like that? A is your answer. If I check the answer on the back, 73 has an answer of A. Perfectly correct. Let's further move ahead. Let's see this so that our practice gets complete. A cathode ray oscilloscope is used to determine the frequency of a sound wave. The diagram shows the waveform on the screen. The time based setting is this. What is the best estimate of the frequency of the sound wave? Perfect. So each box represents 5 milliseconds. Perfect. How many boxes do we have here? 1, 2, 3, 4, 5, 6. Let me count it with the numbers. This is getting thoda sa unclear. This is 1 box, 2 box, 3 box, 4, 5, 6, 7, 8, 9, and 7, 8. 1 second. What am I doing here? Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Basically, 10 boxes is allowing you to cover how many waves? 1. 10 boxes is causing how many waves? 2, 3, and 3.5. So 10 boxes equal to how many waves? 3.5 waves or 3.5 lambdas. One box, or sorry, you can say one wave will be covered or one lambda will be covered in how many boxes? X here. Can I calculate the number of boxes? Yes, 10 divided by 3.5. Your number of boxes comes out to be what? 2.85. The number of boxes required to cover one wave is 2.85 boxes. Perfect. One box represents 5 milliseconds. Okay. What will 2.85 boxes represent? 2.85 into 5 into 10 raised to the power of minus 3. Let's calculate that. 5 into 10 raised to the power of minus 3. This comes out to be what? This comes out to be 1 over time period is equals to 1 over 70 seconds. Perfect. You have to calculate the frequency. What will you do? Frequency is 1 over time period. 1 over 1 over 70. 71 hertz is your answer. 76 answer should be B, and B it is. Let's further move ahead. Let's see this. A sound wave contains a loudspeaker. Uh, a sound wave from a loudspeaker is reflected back along its original path by a reflector. A microphone is initially at point X, perfect, where the sound intensity is minimum, perfect. So let's change this highlighted color as shown. The microphone is moved towards the reflector and passes through 4 more intensity minimas, perfect. So the intensity was minimum at X, then it passes through 4 more intensity minimas until it reaches a fifth minimum at point Y. The distance XY is 70 centimeters. What is the wavelength of the sound? You have to calculate the wavelength of the sound. So if you have an intensity minimum, what does that mean? This is a node, 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 this is a node. The distance between node to node is half lambda. Again half lambda. Again half lambda. Again half lambda. And again half lambda. Perfect. So how many lambdas are these? 2.5 lambda. 2.5 lambda is equals to 70 centimeter. Lambda will be equal to what? 70 divided by 2.5. What does lambda comes out to be? Lambda comes out to be 28 centimeter. D is your answer. If I check this up, 77 should have an answer of D. Yeah, 77 has an answer of D. Let's further move ahead. A glass tube is closed at one end, okay, and has a loudspeaker at the other end, perfect. So if the glass tube is closed at one end, you will have a node here, you will have an antinode here, perfect. A stationary wave is formed with a node at the closed end and the antinode, okay, perfect. The frequency is f naught, perfect. So basically, let's say your length of the complete tube is L. From antinode to node, what is your lambda? 1 upon 4 lambda. 1 upon 4 lambda is equals to L. Your lambda is equals to 4L. Your frequency is equals to F naught. This is given in the question. The frequency of the sound is then slowly increased. What is the frequency of the sound that produces the next stationary wave? For the next stationary wave, you will add one more loop here. Something like this will happen. Something like this will happen. Oh, the last one I drew it incorrectly. Something like this will happen. From node to node, you have half lambda here. Perfect. From node to antinode, you have 1 upon 4 lambda. So what will be your total lambdas here? 1 upon 2 lambda plus 1 upon 4 lambda is equals to L. Can we add this up? Plus 0.5 plus 2.5. This comes out to be 3 over 4 lambda is equals to L. Lambda is equals to what? 4L over 3. Can you observe that your lambda has decreased or divided by 3? What will happen to your frequency? Frequency is inversely proportional to wavelength or lambda. Your frequency will become 3 times of the initial frequency. D is your answer. The answer to 78 should be D, and D it is. Let's further move ahead. A source of sound with constant frequency move towards a stationary observer. Perfect. Okay, so it is moving towards a stationary observer. Okay, whenever sound moves towards a stationary observer, what happens? Your wavelength decreases, frequency observed increases. The observer compares the sound waves arriving at the observer's position with the waves emitted by the source of the sound. What is detected by the observer? A decreased frequency of the sound wave? No. No change in frequency? No. A decreased wavelength? Yes. C is the correct answer. If I check it as well, the answer to 90 is C. Yeah, perfect. Let's further move ahead. Let's further continue with the questions. A source of sound wave is moving at a constant speed directly towards a stationary observer. Perfect. The sound waves have a speed of this. Perfect. So this is the speed of sound V. The frequency of sound is this 480, that is Fs. The observer hears sound waves at a frequency of this. So this is the frequency observed. What is the speed of the source? You have to calculate what? You have to calculate Vs, that is the speed of the source. How will you do that? If the object producing sound is moving towards you, which formula do you apply? Frequency observed is equals to the frequency of sound multiplied by the speed of sound divided by what? Speed of sound minus the speed of source. Okay, let's see this. The frequency of sound is what? The frequency of sound is 480. Perfect. What is the velocity of sound? 340. Perfect. 340 minus Vs is equals to what? It is equals to the frequency observed. That is 650. Perfect. Let's bring this downward, bring this towards the right side. Let's solve this equation. 480 into 340 divided by 650 is equals to 340 minus Vs. Okay, can we calculate Vs? Yes. 480 into 340 divided by 650. Perfect. 340 minus the answer. Your answer for the speed of source comes out to be 89 ms minus 1. A should be your answer. If I check it in the marking scheme, 91 has an answer of A. Perfect. Correct. We are going good. Let's see this. A miniature loudspeaker initially at rest falls vertically from a window in a high building. Okay. When the speaker has fallen a distance of 10 meters, it emits a very short pulse of sound of constant frequency, 256 hertz. So your frequency of sound is 256 hertz. Perfect. In all directions. The pulse of sound is traveling at this. The velocity of sound is also given to you. That is 330 ms minus 1. Is heard by a person leaning out of the window. Okay. So if you are leaning out of the window here and the loudspeaker is falling, the loudspeaker is moving away from you. Perfect. What is the frequency of the pulse of sound heard by the person? We have to calculate the frequency observed in a scenario in which the sound source is moving away. Okay, one thing is missing here. If I write the formula of frequency observed in the scenario when the sound source is moving away, this is the formula. Frequency of sound multiplied by the speed of sound divided by speed of sound plus the speed of the source. The speed of the source is missing here, but you can calculate that. If you pay attention on some things, air resistance is negligible, that means acceleration will be 9.81 ms minus 2. And your distance traveled, S is what? Your S is 10 meters. Perfect. Your S is 10 meters. Acceleration is 9.81. Initial velocity is 0. Can you calculate the final velocity? Yes, you can do that. We will apply what? First of all, to calculate Vs, we will apply what? V square is equals to U square plus 2As. Perfect. U is 0. V square is what? 2 into acceleration, that is 9.81, into the distance, that is 10. Taken under root. 2 into 9.81 into 10 taken under root. The final velocity comes out to be what? 14. The final velocity or the velocity of the source comes out to be 14 ms minus 1. Now you have everything, you can calculate it. The sound source has a frequency of 256 hertz multiplied by the velocity of sound, that is 330, divided by 330 plus 14. What will your answer be? Let's calculate it. 256 into 330 divided by 256 plus, oh, sorry, divided by 330 plus 14. This comes out to be what? 245. The answer is 245 or 246. If I check it in the marking scheme, the answer for 95 is A. Perfect. This was the most difficult question of Doppler effect, so make sure you understand it by playing it back. Okay, let's see this as well. A man standing next to a stationary train hears a sound of frequency 400 hertz. So this is the frequency of sound Fs emitted from the train's horn. The train then moved directly away from the man, and the sound, its a horn. Okay, the train is moving at a speed of this. Perfect. The speed of sound is this. What is the difference in the frequency of the sound heard by the man on two occasions? Perfect. So when the man is stationary, or when the train is stationary, the frequency observed will be the frequency of the sound, that is 400 hertz. Perfect. But when the train is moving away, which formula will we apply? Frequency observed is equals to Fs into velocity divided by velocity plus the velocity of the source. Fs is what? 400. What is the speed of sound? 340 divided by 340 plus 50. Can we calculate this answer? Yes. Let's calculate this answer. 400 into 340 divided by 340 plus 50. This comes out to be what? 348 hertz, or C is your answer. 350 hertz. 98's answer is C. Perfect. And if I check in the marking scheme, okay, so now the frequency observed is what? 350 hertz or 349, you can say. Yeah, you can say 349 hertz. Now the frequency heard is 349 hertz. Perfect. Initially, the frequency heard was 400 hertz. What is the difference between them? This is 349, not 399. What is the difference between the two? 51 hertz is your answer. Perfect. Let's further move ahead. Okay, let's see this question. A source, okay, a source emitting sound of single frequency Fs travels at a constant speed. This is really, really important. Okay, travels at a constant speed Vs, okay, directly towards an observer. Perfect. The source then passes the observers and then continues to move directly away from the observer. The velocity of the source remains constant. The most important line in this question, the velocity of the source remains constant. Perfect. Which graph represents the variation with time t of the frequency observed of the sound heard by the observer? Perfect. What is the variation of frequency observed by the observer? Perfect. So initially when the sound source is moving towards the observer, your frequency will be greater. So either B will be your option or D will be your option. I can cancel out A and see why. Because in that, initially your frequency observed is lesser. Initially your frequency observed is lesser than the frequency of the sound. That is not possible when you are moving towards the observer. Okay. Now, out of B and C, what will be your answer? For this, you have to focus a bit on the formula. Frequency observed when you are moving towards is what? Frequency of sound into velocity divided by velocity of sound minus velocity of source. Can you see the frequency of sound remains constant throughout this region? Yes. The velocity of sound also remains constant. And the source is also moving at a constant speed. That means throughout this entire region, your frequency observed will remain constant. B is your answer. 107, if I check in the marking scheme, B is the answer there as well. Let's further move ahead. Okay, so a student is investigating two electromagnetic waves. Perfect. In a vacuum. Perfect. Wave X has a wavelength of this. This wavelength seems very interesting. If I move this decimal point 2 places forward, this will become what? 520, 10 raised to the power of minus 9. 10 raised to the power of minus 9 is what? Nanometers. And 520 nanometers is a wavelength of what? Visible light. C is your answer. You don't have to read further. Let's further move ahead. Which statement about electromagnetic waves in a vacuum is correct? Amplitude is inversely proportional to velocity. No. Frequency is inversely proportional to wavelength. Yes, B is the correct answer. If I check it in the marking scheme, 127 has an answer of B. Yeah, that's correct. Let's further move ahead. A beam of visible light is in a vacuum. Perfect. So the speed is what? 3 into 10 is the power of 8 ms minus 1. Perfect. What could be the frequency of the light? Okay, what could be the frequency of the light? So the best method to do it is to remember that visible light has wavelengths between what, 400 nanometer to 700 nanometer. If your wavelength is 400 nanometer, can you calculate the frequency? Yes, V is equals to F lambda. V is what? 3 into 10 is the power of 8. What is lambda? 400 nanometer. 400 into 10 is the power of minus 9. What does your frequency come out to be? 3 into 10 is the power of 8 divided by 400 into 10 is the power of minus 9. This comes out to be what? 7.5 into 10 raised to the power of 14 hertz. Perfect. Any similar options? Yes, D is your answer. Let's check out the answer for 128. Yes, 128 answer is D. Perfect. Let's further move ahead. A transmitting mass sends out microwave of wavelength 1.5 centimeter and radio waves of wavelength 1.5 kilometers. Perfect. A receiving aerial behind a mountain can detect the radio waves but not the microwaves. Okay, microwaves, as you can see, has a very small wavelength. Radio waves have a very large wavelength. What is the reasons for that? Radio waves are coherent? No. Radio waves are diffracted? Yes. B could be your answer. Since radio waves have such a large wavelength, they can be diffracted and they reach this recording aerial. However, microwaves having a shorter wavelength cannot get diffracted and reach this recording aerial. Let's see this. A microphone detects a sound wave. The microphone is connected to a cathode ray oscilloscope. The shape of the trace on the screen of the CRO is shown. Perfect. Which property of the sound wave can be determined by using only the measurement of a horizontal distance on the screen and the value of a control setting? So, what can we determine through the horizontal axis? We can determine the frequency. B is your answer. A, C, and D cannot be determined using the horizontal readings or the knob on the horizontal axis. So, B is your answer. A telescope detects and analyzes some electromagnetic radiations of wavelength 2 centimeter. Which type of telescope is this? Yes. If your wavelength is 2 centimeter, which type of telescope is this? Any ideas? The type of telescope is a microwave telescope. A is your answer. Microwaves have wavelength closer to 2 centimeters. Let's further move ahead. Which microorganisms have a length that is equals to the wavelength in free space of electromagnetic wave that is visible to human eye? So perfect. The wavelength visible to human eye is what? 400 to 700 nanometer. Okay. Any answers here that resemble this? Yes, if you see this, A option 0.5 into 10 raised to the power of minus 6. If you take this decimal 1 point, 2 point, 3 point forward, 500 into 10 raised to the power of minus 9 meters. This lies between the visible range of light, that is 400 to 700 nanometer. And this is 500 nanometer. A is your answer. Let's further move ahead. The period of an electromagnetic wave in a vacuum is this. What are the frequency and wavelength of the wave? Perfect. You have to calculate the frequency and wavelength. How will you calculate the frequency? Frequency is 1 over time period. So frequency is 1 over 1 into 10 raised to the power of minus 9. This becomes 10 raised to the power of 9. C is your answer. A very simple question compared to AS physics difficulty level. So this marks the end of past papers for waves. If you have any questions, you may ask in the comments, and the document is attached in the description below.